In this another gas problem, you're given here a gas has a volume of 800 ml at negative 23 degrees Celsius and 760.0 torr. What would the temperature of the gas if the new volume is 1500 ml at 760.0 torr? So if you're going to look at this problem, this is really a Charles law problem. You just look at the change in the temperature resulting to the change in volume. Now, the pressure that you have here are constant. Okay, so usually if you have a problem like this, you have to make sure that your temperature is in absolute scale. So we could say this is your initial volume, this is your initial temperature, but you have to change that one. So your initial temperature, we could say, is just equals to what? 273 plus negative 23 here, giving you 250 Kelvin. Okay, so if we're going to look at the relationship here, the one that is missing is T2. And you have here a new volume. Now you may ask yourself, how about the unit in the volume? Since they are the same, you don't need to convert them to liters. They will just cancel out. They're going to give you the same ratio. So the next thing that you're going to do is look at the relationship. So B1, T1 is equals to B2 over T2. So that's the Charles law. So if we're going to look at the relationship that we have here, so B1, T2 is just equals to B2, T1. So what do we need? We need the T2. So we need to leave this on one side. So we need to divide it with B1. So we're going to put here the 1500 ml times the 250 Kelvin, and then divide it with 800 ml. Okay, so if you're going to look at that, they just cancel out. So the unit that you have here is in Kelvin. So if you're going to do the operation, you will get around 468.8 Kelvin. So I'd like you to double check that just to make sure that it is correct. Okay, now if we're going to convert it to Celsius, so we just subtract it with 273. So if we're going to do that, the temperature that you get is around 195 point. Okay, Celsius. So these are the possible answer that you have depending on what the unit that you're being asked.